students. Today we will learn in which questions chi-square test is used. This is the previous year question from NET exam June 2019. This question is based on the chi-square test. Now, when to use chi-square test? When data given in the question is in the form of frequencies or can be transformed into frequencies. When hypothesis involves one or more than one set of data. Chi-square in contingency tables. Normally, chi-square test is mostly used for the contingency tables. What is a contingency table? A table in the form of rows and columns that displays frequency distribution of two or more variables. This table is usually used to study the relationship between the two variables, whether they are dependent on each other or they are independent of each other. This is an example of 2 by 2 contingency table. Here 2 stands for number of rows and this 2 stands for number of columns. As you can see, there are 2 rows and 2 columns. The total row is not significant here. We don't count this while counting the number of rows. In this table, there are 2 variables. One is the marital status and the other is the intelligence level. The possible questions which can be based on chi-square tests are: number 1, is the difference between marital status of feeble-minded persons and normal persons statistically significant? Whether the married and unmarried group of people differ significantly with respect to intelligence? Is there any correlation between being married and level of intelligence in this combined population? This is the formula for calculating chi-square. Chi-square is equal to summation of the square of the difference between the observed frequencies and the expected frequencies divided by expected frequencies. Let us understand this concept with help of an example. You have been given the observed frequencies for feeble-minded married persons and for normal married persons. Then for feeble-minded unmarried persons and for normal persons who are unmarried. These are the expected frequencies. First, we will calculate the difference between observed frequencies and expected frequencies. Then we will square the difference. The square of the difference will be divided by expected frequencies. Then we will calculate the total of this column, which is our answer. 7.10 is the value of chi-square. Now, how do we interpret this value? Here, the null hypothesis is that the two variables, the marital status and the intelligence level, are independent of each other. And the alternative hypothesis will be that the two variables are dependent on each other. Now we will calculate the degree of freedom. Degree of freedom is equal to number of rows minus 1 multiplied by number of columns minus 1. Here the number of rows is 2 and number of columns is also 2. So 1 multiplied by 1 is equal to 1. This is our degree of freedom for this particular example. The calculated value of chi square is 7.10. This is the chi square table. Since our degree of freedom for our question is 1 and we want to find the value at 0.01 level of significance. So at degree of freedom 1 and at level of significance 0.01, the value is 6.635. This is the value of chi square at 0.01 level of significance and degree of freedom 1. Now let's see how we will interpret the result. The calculated value was 7.10. The table value is 6.635. Calculated value is greater than table value. So we will reject the null hypothesis because the calculated value is greater than the table value. This means that two variables are dependent on each other. This was our alternative hypothesis and we have accepted this because null hypothesis has been rejected. Now, for 0.05 level of significance and degree of freedom is equal to 1, the value is 3.841. At 0.05 level of significance, the calculated value is 7.10 and the table value is 3.841. Since calculated value is greater than table value, the null hypothesis is rejected. The two variables are dependent on each other. When calculated value is less than the table value, then null hypothesis is accepted and the two variables are said to be independent of each other. When expected frequencies are not given, then you have to calculate them. Let's see how we calculate the expected frequencies. This is the example. Here, observed frequency is given, but expected frequency is not given. So the formula for calculating expected frequency is row total into column total divided by total number of observations. Now, as you can see, for this particular row, the total is 84 plus 111 is equal to 195. For unmarried, 122 plus 95 is equal to 217. And for calculating n, we will add 195 to 217. We will get 412. This is the cell number. This is the cell number where this is the row number and this is the column number. So for cell number 11, the expected frequency will be FE11. Row total here is 195. Column total is here 206 and n is 412. So the value comes out to be 97.5. Similarly, we will calculate all the other three values for all the other three cells. For FE12, the value is 97.5. For FE21, 108.5. For FE22, it is 108.5. Let's see how our table looks like now. Now, this is the table for both observed frequencies and the calculated expected frequencies. 97.5, 108.5, 97.5, 108.5. Now, what do we do when the expected frequency is small? We use Yate's correction when the frequency is small. Small means it should be less than 10. And which frequency is the expected frequency? The degree of freedom of the given table should be equal to 1, which is possible in the case of 2 by 2 table and 1 by 2 table. Both these conditions should be fulfilled for applying Yates correction. Note here that the expected frequency's value should be less than 10. Even if only one value is less than 10, you have to use Yates correction. Let us understand Yates correction with the help of an example. This is the table 2 by 2 table, that is degree of freedom is equal to 1. You have been given observed frequencies and the expected frequencies. As you can see here, this value is less than 10 and this value is also less than 10. So we have to use Yates correction for calculating chi-square. For calculating chi-square, what we do is we just subtract 0.5 from difference of observed frequencies and expected frequencies. Then we square this value. Then the squared value is divided by the expected frequency. So the only thing that you have to do is you have to subtract 0.5 from the difference of observed frequencies and expected frequencies. The total you will get here is 3.42. This is the chi-square value. This is the practice question for you. You can solve it and check your answer from here. If you have any doubt or you have any suggestion, please mention it in the comment section below this video. This is the name of the book I have referred to for preparing this presentation. If you like my video, please like the video and share it with your friends and subscribe to my channel for more videos. Thank you.